In the winter, when it's cold, you put on a jacket. And in the summer, when it's hot, you go to a swimming pool to cool down. But how do plants actually deal with different temperatures? After all, you can't actively change your location. Plants on Earth often struggle with cold winters, where temperatures are often below freezing. Many trees growing here, such as oaks or birches, their leaves in autumn. But why do they do this? A lot of water evaporates over the leaves. In summer this is also good because the evaporation cools the leaves and protects against overheating. In addition, it can absorb water via the root again and is thus supplied with important nutritive salts. In winter, the soil and the water contained therein is frozen. If water is lost through the leaves, this can't be absorbed from the soil, so a deciduous tree would simply dry up in the winter if it carried its leaves in winter. In grasses, on the other hand, the above-ground parts of the plant die off. Only the soil-protected parts of the plant survive the winter. Many plants also survive the winter as onions or tuber, including tulips or daffodils. In other plants, only seeds that are less susceptible to cold than the whole plant survive. They germinate again next year, and there are even plants that actively produce heat in winter in order to be able to bloom already with snow, for example the snowdrops. But summer can also be dangerous for some plants. Too high temperatures cause important proteins to be destroyed for the plants, and thus they can no longer work properly. The plant must therefore protect itself from this. At high temperatures, they often release a lot of water from the leaves, which evaporates on the leaf surface, which has a cooling effect on the leaf and protects against overheating. Plants must not lose too much water in summer, because the water there is often limited. A dense final tissue of the epidermis with a cuticula prevents too much water from evaporating.
Are animals which body temperature changes according to the temperature around them.
Homeotherms, or also homeothermic animals. Homeothermic animals classify as birds and mammals. So for example, in my case, a giraffe. Homeothermic animals are not affected by their environment, since their bodies have the ability to regulate their temperature through metabolism, like sweating or other stuff that they can do to build up or lower their metabolism, which highes or lowers the temperature according to the environment. So if the environment has a high temperature, they lower their metabolism and they get colder. If the environment is colder, they higher their metabolism. This, though, requires a lot of food to make up for the energy they need for the metabolism. These are just references of food. Of course, please don't give your birds or anything burgers or hot dogs. I would not recommend. When you think about temperature according to environment and different types of animals, there's also the geographical aspects. In this aspect, we've got two rules that act like a yin and yang. The first one is the Allen's rule. It basically is just the body parts of the body. So the more body parts or the longer or bigger body parts you have, such as you can see in these examples with the big ears in warm environment or small ears in cold environments, the bigger, the more heat release. So the smaller, the less, which is good because in warm environments, you don't want any more body heat. The second of the two rules is the Bergmann's rule. It's kind of, as I said, like the yin and yang. It's the counterpart, which doesn't focus on the body parts, but on the body volume itself. Because the bigger the body, the more heat storage the body has, and the more heat can be produced and kept. And in cold environments, as you can see here, the body parts are small and the body is big. In the warm environment, though, the body parts are big and the body itself is small. So they're completely perfect for their environment.